Okay, we have come to the final question of example 5.1. Okay. Okay, previously we showed the flow profile in question F. Okay, so we know that the first profile is M1 and the second profile here is M3. Okay, so let's read the final question. On an EY diagram, plot all the relevant profiles and energy depth combinations for this problem. Show that the system analyzed amounts to an energy conserving loop. Okay. Okay, so for this question, it's helpful if we can determine, because from, okay, so this is the answer. Okay, this is the answer from the textbook for question G. Okay, so this is the answer. So you see that from the answer we have like A, B, C, D, E. So what it means? This relates to the low flow profile that you have sketched. Okay. Okay, so this, I repeat, the energy Y diagram is related to the flow profile that you have sketched, this one. Yeah. So since you see that we have A, B, C, D, E, so where is this is A, B, C, D, E in the flow profile? So actually A is here because you start with normal depth. This is A. Okay, and then you go to the sluice gate. This is B. Okay, and then you go to the gate, bottom of the gate. This is C. Okay, so from the bottom of the gate, you go to the Y conjugate. So Y conjugate here at this point, this is D. Okay, and from D, the flow encounter a hydraulic jump and goes back to the final flow, final depth, which is back to normal depth. So all these were given from the question. So it starts with normal depth and it ends with normal depth, upstream and downstream. So this is the final point, which is E equals to Y naught. Okay. Okay, so from A to B, you see that the depth increase because A we have 1.26 and at point B we have 2.24. Okay, so when you see in the EY diagram, from point A to point B, the depth increase. Okay, so we also have increase of energy. Okay, so in this case, let's look here. This is also from textbook. Energy gain on M1. So this is at profile M1. So the change of E is equals to E at when Y is equals to 2.24 meter, which is here at point B. Okay, so this is at point B. Minus when E at point A. Okay, so here we have energy gain of 0.79 meters. Okay, so from this point to this point, the energy we have here is 0.79. Okay, so let's look at point B to point C. So from point B, you know here, this is just before the sluice gate, and point C at the sluice gate. This is, since it is a sluice gate we have here, so the energy is conserved. Okay, so the principle is that energy is conserved. So when the energy is conserved, so when you look at the EY diagram, you see that from point B, we go to point C. So this is alternate depth. So when we have alternate depth, the first one will be subcritical, right? I hope you still remember this. And at the bottom part, which is at point C, we have critical. critical depth, supercritical depth. Okay, supercritical depth. So this is the alternate depth for this situation where energy is conserved. Okay, so now we have from point C to point D. It seems like we have energy increase. Sorry, not energy increase. We have depth increase because point C is lower than point D, right? And it's in the supercritical area. So since it goes to the left, so from high energy to low energy, so which means we have energy loss. Okay, so energy loss from at profile M3. Okay, so we are talking about this section over here. Okay, this section from point C to point D. You see that we have increase of depth, but since it is in the subcritical and supercritical region, so it moves to the left, so we have loss of energy. Okay, I hope you can understand this. Okay, so energy loss on M3, this profile M3, so this is the profile for M3, is equals to E at Y conjugate minus E at Y gate. So 1.59 minus 2.34. So the energy loss is 0.75. So if you don't remember how did we get these values, you can refer to the previous videos. Okay, or you can always refer to the textbook. Okay, so I hope you can understand how the energy behave from point C to point D. Now we have from point D to E. Okay, so we have from point D to E. I'm trying to find my cursor. I always lost it. Okay, so it's here. So okay, so now we are looking at point D to point E. Okay, so because we know that there is a hydraulic jump here, so this is called as Y conjugate, and we conserve the momentum. I mean, the flow conserve the momentum, but not energy. So there is losses of energy in the hydraulic jump. Okay, but okay, you can see that from point D to point E, the depth increase. So from 0.73 to 1.26. Okay. Okay, so from this point, okay, from D to E. Okay, so from D to E, the energy increase. Sorry, the depth increase, but we have energy loss. So energy loss in hydraulic jump is equals to E at normal depth minus with E at conjugate depth. So we have 1.55 and 1.59 minus 1.59. So we have negative 0.04. So we lost this amount of energy, 0.04 meter energy was lost in the hydraulic jump. Okay, so in this specific case, so in the case that we have just solved, the vast majority of energy loss, by the flow is on the M3 curve rather than within the hydraulic jump. Okay, so we lost a lot of energy. Where? Here. Okay, M3 region, we lost a lot of energy if we compare to this point. Okay, here we gain energy. Here we lost energy. Okay, but here the energy is conserved. Okay, so we have this loop of energy in this situation. Okay, I hope you enjoyed this video as much as I enjoy explaining this to you. I know that we took so much time to explain. I mean, I took so much time to explain to you example 5.1. So I hope you can follow all the reasoning behind this question and answer. So if you have any question, don't forget to ask me. So I'll see you in the next video. Thank you so much.